Hi friends, my name is Narasimha and I am pursuing my BTech at Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Today, as a part of my AIT Tech Talk videos, in the subject of human-computer interaction, I want to explain about a topic named Rule-Based System Development for Conceptual Aircraft Design. So, for example, we want to design any of the aircraft or any of the product, we should follow some of the rules and regulations. Means it is commonly known as protocols. So by using this type of rules, we will build a product very clearly. This is a step-by-step process which is being involved in the construction process. So coming to the introduction. In the aerospace industry, a rule-based system is developed to enhance the autonomy of commercial transport aircraft design. This cognitive system translates performance requirements into design constraints, breaking down complex problems into manageable sub-problems. The system matches design goals with action results, iteratively refining conditions until all requirements are met, providing a systematic approach for acquiring and applying design knowledge in the aircraft design process. For example, if there is no presence of rules, means there are no rules which will be followed for constructing any of a product. Imagine, if there are no rules, we have to face the problem, face the consequences which are being involved in the process, and we will not know what to do for the further step because there is no particular rules which will be followed. So we cannot refine the process and we cannot get the actual results as on which we want to get as an output. But if there are any rule-based system is being presented for us, then we can easily follow the rules and iteratively we can refine the problems and the consequences which are being arrived to us, and we can at last we can get the actual output which is required to us. Next, this is an implementation of rule-based reasoning in engineering design. Here you can see the design requirements and specifications which are being applied to the engineering knowledge, and at last it will give an output as a design space. In the engineering knowledge, you can see the knowledge represented by rules. That is, here you can see some of the rules from rule 1 to rule 9. All rules are interconnected to each other. Means rule 1 is connected to 2 and 3, 2 is connected to 6, etc. So starting from rule 1, if we follow all rules in the step-by-step process, and we apply these design requirements and specifications to this engineering knowledge in this criteria, then we can get the actual output according to requirements of the user or the consumer. Please have a look at it. Next, introduction to aircraft design process. Aircraft design is driven by stakeholder requirements and specifications. The design phase starts with system requirements that define design goals. Performance constraints such as range and takeoff distance are crucial in early design phases. So this range and takeoff distance are very important when we are designing any of the aircraft. So challenges in conceptual design. Multiple solutions exist for the same requirements in conceptual design. Existing analysis tools require mature and detailed data and are computationally expensive. It's very costly. Design engineers need to leverage knowledge and experience from previous designs. So from previous designs, the design engineers should gain the knowledge and they should prepare a nice design by following the previous rules, but by implementing in different way. Role of artificial intelligence. AI aids in representing and searching for design knowledge. Knowledge representation is crucial for AI systems to perform intelligent behavior. Search in AI focuses on exploring the design space to find the best solutions. So for example, I will say how AI is used in our day-to-day life. In Google Chrome, when we have to search about any topic, if we search the topic in the title bar, means in the search bar, we will get different types of web pages and web links. So by clicking on any of the web links, we can get the information, and if we will prefer the web link which gives actual and real information according to us. But nowadays we are using the chat GPT. Means when we type any of the question on the search bar, then we can get directly the answer without having the web links. Means this is the usage of AI. Means we can get the knowledge about the previous models and we can know about the features, what have been considered in this previous knowledge, and we can get the knowledge from it. Coming to the human-centric design. Human thinking is holistic, but It's essential to scope down and break the design problems into manageable tasks. Understanding human thinking patterns informs the development of engineering principles. Next, mental representations and AI. Human knowledge consists of mental representations like logic, rules, concepts, images, cases, and connections. AI represents knowledge as data structures and applies algorithms to these structures. So, as a human, we can think a question in different number of ways. Every human will not think a question for an answer for a question in the same way. So we'll think about his logic and also the previous experiences and the rules and the images will come into the brain. But the AI represents the knowledge in the form of data structures. Means any of the data structure like stack, queue, or anything which is being used for storing the data in a systematic manner and replying the question, replying the solution for a question. Types of reasoning in AI. What are the types? Reasoning by learning utilizes neural networks to model relationships between inputs and outputs. Reasoning by analogy leverages previous experiences for solving new design problems. Reasoning by logic is applied in expert systems like rule-based systems. Coming to the structure of rule-based systems. Here we can see this inference engine is the main engine, which is interconnected between the knowledge base and the database. And next, it is being directly connected to the user interface, and it is being directly connected to the working of a person. Let's have a look at it. Come to the conceptual aircraft sizing and synthesis. The conceptual aircraft sizing and synthesis process encompasses three key components that are constraint analysis, mission analysis, and sizing. It compensates with the definition of design requirements and mission segments. Finally, the sizing process is initiated, iteratively calculating the takeoff gross weight using weight fractions, payload, crew weight, and empirical relationship for empty weight. Next, aircraft performance requirements. What are the performance requirements? You can see the takeoff, climb, cruise climb, approach. So for designing any of the aircraft structure, so these are some of the key components should be considered by which we can design any of the aircraft, means the engineers can design any of the aircraft by following the rule-based systems. The takeoff, for example, they can say takeoff distance must be less than or equal to 2,950 meters. Takeoff safety speed must not less than 1.13 vSSR. And also climb, the time to climb from sea level to initial cruise altitude must be less than 30 minutes. And cruise climb is the cruise Mach number must be 0.82. And approach, for example, these are some of the approaches given, that is stable approach and approach path angle of 3 degrees must be maintained. Approach speed must not be less than 1.23 vs, that is reference stall speed, etc. Next, coming to the implementation of constraint analysis in rule-based systems. In the context of conceptual aircraft sizing and synthesis, a rule-based system is utilized to conduct constraint analysis for a generic commercial transport aircraft. Coming to the RBS, that is rule-based systems development for constraint analysis is carried out by using Python. So, which we are familiar in our day-to-day life for coding process, that is Python, C, Java. And we can consider this Python as easy language to be understand for any of the person who are familiar with the English commands, and they can easily understand what is the code written by the programmer. So for that purpose, RBS, that is rule-based systems, are using Python as a framework and as a coding platform, where the algorithm selects the constraints, retrieves corresponding equations, and prompts users to input missing knowledge through an interactive interface. So the engineers, first of all, they want to acquire the knowledge about the previous experiments, and also they should get the knowledge base. So for that purpose, they will use the search engines, and the same way they will give the prompts, means the end user boxes in which the users can give the inputs to the engineers, means the considerations which are being considered by the users as an outputs are the requirements which we are being want by the consumers. Next, the inference engine plays a crucial role by understanding dependencies between equations, setting goals, and recursively inferring values until all necessary information is embedded in problems logical decomposition. Next, coming to the conclusion. This RBS offers an interactive means of acquiring design knowledge, guiding users to address missing information and gradually building an extensive expert knowledge base. This systematic knowledge acquisition process holds significance in systems engineering and warrants further exploration, including the integration of various engineering knowledge forms, and complementary AI methods like case-based reasoning for leveraging past design experiences. So once have a quick recap of all the things which I have said before. This is a main topic, that is rule-based system development for conceptual aircraft design. Coming to the introduction, a rule-based system should be developed for development of conceptual aircraft design. Coming to the process, that is, here are some main parts, that is design information and specifications are applied to the engineering knowledge where all rules are being presented in that knowledge as a protocol by which the process will be continued from rule 1 to rule n. And by following this process, the design space means the actual output can be delivered by the engineers. Coming to the introduction, and next is the role of AI. We all are familiar with this word AI, which is being gradually increasing in our daily life. And all our robots or any AI machines, ChatGPT, search engines, all are being developed by this main content. Next, mental representations and AI types of reasoning, that is 3 types. And next, this is a motivation for RBS. And this is the main structure of RBS, that is knowledge-based database, which are being interconnected to the inference engine. And it is again connected to the user interface. And this is the main inference engine is the main for getting the knowledge base and database. This knowledge base is about the requirements of actual project, and this database is about the features extraction of the previous projects. Which I said in the conclusion that there's some of the AI methods like case-based reasoning for leveraging past design experience. Means for example, for knowing about the past experiences, this case-based reasoning can be used for knowing about the database. So thank you, friends. I hope my lecture is useful for you. Thanks for watching. Thank you.